Truth tables. Truth tables are used to make statements and determine if they are true or false, and then to make an argument with multiple statements and decide if that conclusion is true or false. Let's say I considered P to be a simple statement. My simple statement could either be T, true, or F, false. And that in itself does not do a whole lot, but we're going to build on these. So the next building block is the negation of P. The negation of P is written tilde P. It represents the opposite values of statement P. So in the table below, on the left, I have statement P. If the statement is true, then the negation of P is false, or the opposite of P. And if P is false, then the opposite is true. Now let's look at a truth table for conjunction. Remember, conjunction is the word and. The conjunction is true if only both P and Q are true. So let's take a look at how this table is developed. First, I write down P. Now P could either be true or false. And you'll notice that I've written true twice. That's because statement Q could be true or false. So in this first row where I have true, true, that signifies that statement P is true and statement Q is also true. But the second row shows that statement P could be true and then statement Q could be false. So while statement P is true, Q could be either true or false. And similarly, while statement P is false, statement Q could be either true or false. So when we have two simple statements, we have 4 rows. And those 4 rows are true, 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 false, false, true, or false, false. Then we develop a third column. And this third column is the conjunction, because that's the situation we're looking at. The conjunction uses the and symbol. And we're looking for where P and Q are both true, and that gives us a true statement in the end. So when we have true, true, our conjunction is true. But in any other case, our conclusion is false. And that's because they both have to be true in an and situation for the conclusion to be true. But what if we were doing disjunction, which is an or? Well, we set up the table the same way. True, 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 false, false, true, and false, false. Now with an or situation, just one of them has to be true. So for example, true, true, well, that conclusion is true. Or in the next row, we have true or false. We just need one of those to be true for the conclusion to be true. In the third row, we have false, true. We just need one of them to be true. So then we have true as a conclusion. False, false is false. The paragraph above may help you out with understanding or. I want to give another example. Let's say I tell my son Michael, you can have a cookie or you can have ice cream. In our family, that would be assumed that Michael can just have one of them. But in mathematics, the word or would mean that he could have a cookie or ice cream. He could have both of them, and that would be the truth. And he could have a cookie and no ice cream, and that would be true. He could have no cookie and ice cream, and that would be true. But no cookie and no ice cream would be false. That would give him no dessert. Let's look at the last situation of truth tables. In this one, I'm going to create a truth table for not P and Q. So I begin by creating the table of P and Q. It always helps me with the first 2 columns being my simple statements of P and Q. I still have true, 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 false, false, true, and false, false. Then I like to create my not P. My not P statement is the opposite of all of my P's. So false, false, true, true. I've highlighted or bolded in black. I have made the font bold for the columns of Q and not P because they are what the argument actually is. The argument is not P, and Q. So I'm looking for both of those being true to be able to have a true conclusion. If I look at Q, not P, true, false, I end up with false because one of those is false. If I have false, false, then I have false. This condition, true, true, gives me a conclusion that's true. And then false, true, gives me false. And that is how I would finish off a truth table of not P and Q.